Welcome back. Today, we're going to be talking about Archimedes and buoyant force. Now, who is Archimedes? Well, he lived in ancient Greece, and he was tasked with finding the volume of a crown. Now, this is annoying, so I'm going to take it off, but they could not measure the volume of irregular objects, because you know when you have like a cube like this, length times width times height, but when you have a crown, it's a lot harder to do all those little intricate shapes, especially when, you know, technology at the time, they weren't very accurate. So, one day, he was going to take a bath. Thank you for the diagrams, Leo. And the bath was filled to the very top where, you know, the maximum amount of water could go. And so when he got in, water spilled out of the sides, and he had an idea. If you could put something in water, the amount of water displaced would be equivalent to the volume of that object. So he used it for the crown, and it's a principle that many people use today. So, first let's talk about regular objects, like this cube. Now, we're going to start filling out your chart here. You're going to do this at home. I'm not going to actually, you know, do the calculations. Just know that I could, if I wanted to. So, we're going to take a look at this. Now, my mom is going to get in close here, and we're going to do the measurement of one side of the cube. Can you see that in centimeters there? So, if you take that, that would be the length, and it would also be the width and the height. So, you know, you do that calculation, you put it on that chart, because my mom told you to. So when you find that out, we're going to start talking about this. So, when you put it in here, water spills all over the place. Right? Yeah. Gotta, you know, some of that water out there. Now, if you wanted to know the volume of the cube, and, you know, you couldn't use measurements for whatever reason, you could put it, take the water, and put it in a measurement. And that, drop there, should be the same. Now we're going to talk about weight in air versus weight in water. So, actually I'm going to have to put this back in here for that part. If you're going to talk about buoyant force is the force that the water puts back on objects that are suspended in it. How do you know how much it would be? It's the same amount as the weight of the water which is displaced by the object. So this weight is the amount of buoyant force that would push back on this cube. So if you're going to talk about the weight of this cube in the air, you can see it right there in newtons. Now what's the difference when I put it in water? Very carefully, try not to really touch the sides too much. And look at that, it's less. How much less? That's up to you to figure out and put on your chart.